So yeah, so I know yours is not color coded, but it's just kind of give you an idea of what we're doing, okay? So what we're doing is this guy here. This is what we are doing today. Finding that area, okay? How do we find that area? Well, you find the area under the top function, right? It's green on mine, right? So the area under F is all of the green, but we don't want all of the green, right? We want to subtract the pink color here, right? So how do we do that? Well, we subtract the area under the lower function, right? So we find the area under F, we find the area under G, subtract them, and we get what we want. Okay, we get what we want. So essentially you're just finding area under the curve, but subtracting them. You can do it separately, here minus this. You can see they do it separately, or you can combine them together. Doesn't matter, okay? It doesn't matter because it's all the same thing. So that's what we're doing today. We're finding area between curves, okay? Okay, so how do we do that? Area, the bounds are the same, right? Left to right, the bounds. So when I say the bounds, I mean where does the area start? Where is the bounded area? From the left to the right, we always use the x values, right? Top curve minus bottom curve. Okay, so the steps, I say draw a picture if not given. Picture helps, okay? Calculator will help with the picture if one's not given. Like on example number 1, they give us a picture, they give us the graph. But on the rest, they don't. So we need to come up with a picture because you don't know which one's top and which one's the bottom function until you see a picture, okay? Find the bounds. Sometimes they'll give you the bounds. Sometimes they're obvious. Sometimes they're not. So sometimes we're going to have to use the calculator to find the bounds. And then find the area. Okay? All right, so let's look at number 1. Like I said, it's pretty straightforward because you guys have done this before. So let R. So again, so on mine, it's kind of highlighted green. I always highlight the area bounded by the two functions. When I say bounded, I mean restricted between things, right? Bounded means restricted between things, right? So the green is what we're looking at, okay? So we have two functions. We have f of x, which is x squared. We have g of x, which is negative x squared plus 2x. They've given us a picture. Okay, so we got to find the area of R, capital R. So the first thing you got to do is you got to determine what the top function is and what the bottom function is, right? So we have two functions. We have, this one here, right? And then we have this one here. Those are the two functions. They don't tell us which one's G and which one's F. So we have to figure that out. So let's start with the pink one, the happy face one. Is that G or F, and how do we know?
F.
It's F. How do you know? Good.
Because it's an exponential function.
It's
Positive.
it's a quadratic, right? It's a quadratic. Quadratics either look like, quadratics either look like this, or they look like this, right? How do we know it's a quadratic? Because the second power is the biggest, right? So anytime you have second power the biggest, it's either going to look up or arrows down, right? So G is the upside down, arrows down. F is the arrows up, okay? So that means this guy is f of x, this guy is g of x, okay? So let's set up what we're going to put in the calculator. So capital R, because that's the region that we need to find, is, we said the top function was g of x, right? G of x is negative x squared plus 2x minus the bottom, right? Which was x squared.
I think there's a column outside of the
Yeah, go ahead. Yeah, just about that. Dx. Okay, I'm going to put them together. You can separate them, but I'm going to put them together like this. Okay, so top minus bottom. Now we got to figure out the bounds. The bounds is the restricted area. So where are the dots, or where are the bounds for the restricted area of the green?
0 to 1.
We got one right there and one right there, right? That's where they intersect. That's where the restricted bounds are. So we use the x value. So it looks like 0 is x to 1, right? 0 to 1. So we're going to go, those are going to be our bounds. 0 to 1. Okay? Before I put it in my calculator, I like to simplify it as far as I can. So I can subtract. So when you subtract, you're actually going to combine these two guys here and make negative 2x squared plus 2x. Okay? The rest we're going to put in our calculator. So calculations, we go to Toolbox, Calculus, Toolbox, Calculus, bounds, 0 to 1. And then we have negative 2x squared minus, or plus 2x. No, not that. X. Okay. Enter 0.33333, it's 1/3. 1/3. Okay. Area under the curve. Area between those two curves is 1/3.
It says without using a calculator, so is there a different...
Oh, without using a calculator, yeah, I didn't read that. So most of these, the ones I'm going to give you are all calculator questions. There are sometimes, because you can do that. Yeah, so that's a great question. So it says without a calculator. So how would we do it without a calculator? You would just antiderivative, plug it in. Yeah. Because I think this is the only non-calculator question. So yeah, if it is, almost always these are going to be calculator questions. If it's not, it'll be a question like this where you just find the antiderivative, plug in 1, plug in 0, subtract, get the same thing. Okay? Okay, let's go to B now, or number 2, right on the back. Let's go to number 2 on the back. Okay, so this one says use a calculator, so we can use a calculator. The rest of them are going to be calculator questions. Okay? Okay, so we have a picture. They've given us a picture this time. So the first thing is we need to find area between the two curves, right? So we have a parabola. I have a parabola here. And then I have a line. Well, the parabola is going to be f, because that one has an x squared. And negative g is just a line, because the highest power is 1. Okay? So I'm going to set up my... So the top is the parabola, right? The top is the parabola. That's the top of the green. The bottom of the green is the line. So it's going to be negative 3x squared plus 5 minus negative 4x dx. The bounds. Okay, so we got the left dot looks like it's right there. The right dot looks like it's right here. So the left dot looks like it's in between negative 1/2 and negative 1 and up maybe 3, right? We don't really know, right? Same thing with the bottom, the right dot. It's right a little over 2, down between negative 8 and negative 9. So what we have to do first is go to the calculator and figure out what those bounds are. So we got to figure out where they cross. Where are those two guys crossing? So we're going to have to graph these two on the calculator. Okay? and figure out where are they intersecting. Okay, so you're going to go to the calculator, you're going to go to the graph, so you're going to go home to the home page, go to the grapher. Okay, the first one we're going to plug in. Doesn't matter which one you plug in, order doesn't matter, because it'll look the same. So negative 3x squared plus 5. That's my first one. My second one is negative 4x. Okay. Go to graph. It's the same picture we have. Okay. I want to figure out where they cross. So I'm going to go up. I'm going to scroll up to where it says calculate. So from the graph, I'm going to scroll up and over to where it says calculate. Pick one. It doesn't matter which one because we want to know where they intersect. So I'm going to click the top one. I'm going to find intersection. So the first intersection I see negative 0.7, so negative 0.7863, all round. Okay, that's the first one, and then 3.1452. That's the first spot they, right? And then I scroll, I use my cursor to go right, and there's another spot. 2.1197, 8.476, 4786. That's where they cross. So let's go back to here. So I have the 2 points. I only want the x, right? Remember, I only want the x. So the lower one goes at the bottom, the bigger one goes at the top. So we have negative 0.7863. And then the top we have positive 2.1196. Or 97. 2.1197. Simplify, we can add, these two become positive. So now we're going to go to our calculator and figure out what the area is. So I want you to go to your calculator and figure out what is the area for this guy. Approximately, right? It's not going to be an exact answer because it's going to be approximate.
12.269.
There you go. Should be 12.269. Yeah. 12.269. I put the waves because it's approximate, we rounded. Okay. Not too bad. All right. The next one, the one right below it, they don't give us a picture. So the first thing we're going to have to do is get a picture. So go to your calculator, graph those two, graph F and G. And also, they have two others. So there's actually 4 graphs here. There's F, G, and then they want you to graph the vertical lines x equals 0 and x equals 1. I'll show you how to do that. It's not that hard. So do F and G, and then I'll show you how to graph. So F is e to the x, e to the x. G is just x. Okay, so how do I graph x equals, right? Because these are all y equals. How do I graph x equals? So what you do is You go to, let's see, hit enter, and then go to the templates. So scroll over to the templates, hit enter, and then go down to where it says x equals. Should be down here. Should be, it says a inverse function. It says x equals. Okay, x equals, and then just erase what was there before, and then you can put x equals 0, x equals 1, boom, there you go. Okay, so now I have 4 graphs that I'm graphing. And it should look like that. So let me zoom out. There we go. So I'm going to cut and paste this guy. So what I want you to do is draw this, sketch this in your notes. Because it's a lot easier when you have a picture in front of you. So as best you can, draw a little sketch like this in your notes. Doesn't have to be color coded, just something to look at so that you can draw on it. Okay? So the red is f of x. The blue is g of x. The orange line is x equals 1. Let me label these. And the green line is x equals 0. Okay, so this is x equals 1, x equals 0, g of x equals x, and then the red here is f of x equals e to the x. The area where it's bounded is here. Call that R. Okay. So just give yourself a quick sketch of it to see what it looks like. Okay, the sketch doesn't have to be perfect, it's just a sketch, but it'll help you see to do the next steps. Because most of the time, they won't give you a picture. You'll have to use the calculator to give yourself a picture. Okay? So we got to find the area of R. Having the picture in front of you, we can tell which one is the top and which one is the bottom.
One is the top and here's the bottom? Or,
No, which function is the top of the green? Like which?
E.
The red, right?
Yeah.
The red, right? E to the x. So that's going to go first. And then which is the bottom?
G of x.
G of x, which is x, right? So minus x. Now, where are the bounds? Where is the left bound and where is the right bound?
0 to 1.
It's a 1. There we go. Okay. So we put those in your calculator, and you should get 2 point something. I got 2.128.
I got 1.2.
I got 1.2.
All right, let's take a look. Did I forget something? No, 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 no. I forget something? Okay.
Maybe because we had one?
I don't think we had one. Let me see. Let me see. This is just what I got last year, so it could have been wrong. I don't know. Let's see. Okay. We got. Where is it? Where is it? Where is it? Toolbox. Calculus. 0 to 1. E to the x. Oops, I don't want it up there. I want down. Minus x, right?
Evening alpha.
Yep, there you go. Yep. Yeah, I was off by a whole unit. I don't know why. Yeah, 1.128. 1.128. Don't know where I write to. 1.128. Done.
Isn't it 1.218?
Yeah, 1.218. That's maybe where I. 1.218. Okay. All right. Okay, so let's look at the next one. Okay, so let's go to number 4 on the back. So what I want you to do first is use your calculator to give me a picture. Sketch a picture. Use your calculator, get a picture, and then sketch that on your page. Okay? That's what I want you to do first. Take a few minutes to do that. So we have this guy here. You got a red and a blue. So the red represents f of x. The blue represents g of x. Depending on which one you put first. They usually give red the first color and blue the second color. Okay. So that's what the picture looks like. So now that we know that, we know that f of x goes first. Minus x to the 4th minus x dx. And it looks like the left bound is 0. It looks like it's 0. But the right bound, I don't know what it is. 1.2? 1 something? Yeah, so we're going to need, yeah, so I haven't figured that out, right? You guys have. So I need to go figure it out.
I got the same thing, but like, it's different. Am I done? Maybe I'm stupid.
So I'm going to go up to calculate, pick any of them, find intersection. So 0, 0 is one intersection. The other intersection is what you guys are saying, 1.1808. 1.1808. All right, 1.1808. So that's what we're going to put down here. And then we're going to find that area. And I got this. When I put it in the calculator, this is what I got. Has anyone done it?
Yeah.
Okay, good. Okay. Okay.
So it didn't how far look, because it just says use the calculator to find the bounds. It doesn't say when to round it to. So we always just round it to the thousands? I mean,
Yeah, I go 3 space. Yeah, I go. Yeah, 4th, 5, 3 or 4 spaces. I go. Yeah, that's fine. Yeah. If you go 3 spaces, you'll be fine. If you go 4 spaces, even better. Don't go more than 4. Okay. Okay, so let's look at the next one. Okay, so the next one, I want you to do the same thing. Give me a picture. First thing, give me a picture. It's good practice for your calculator, to use your calculator, to use the calculator.
That's a weird looking
Okay. So we have 3 graphs. Y equals square root x, that's the red on mine. Y equals 0, that's the blue on mine. And y equals x minus 2, which is the green on mine. The area bounded, it means surrounded by all of those, is going to be right here. Okay. Okay, so before I do this, or actually, you know what? Let me start doing this. What's the top and what's the bottom?
The top is y equals x minus 0.
Y equals x.
Or minus 2.
Oh.
The last one.
Oh, so x minus 2? So that's actually the green.
That's the.
That's the green one. For me, that's the green.
You sure? Mm-hmm. Because the square root of 4 is 2. So,
So the square root is this, the curved one is the square root one, the red. And then the y equals 0 is just the x-axis here. Yep. Okay, so the red looks like it's the top, right? What's the bottom?
Y equals x minus 2.
That's the green, right?
And y equals 0.
So here, look at here. We're going to have an issue here. This is the first one we're going to have an issue. We're going to have an issue because part of it, the bottom is y equals 0, the blue, right? And part of it, like right here, it changes, right? Oops. Right? To the left of that dotted, the top is the red, the bottom is the blue. Good, right? But then on the right of the dotted, it changes. The red is the top, the green is the bottom. So we have 2 parts that we need to contend. So we have 2 sections. So I'm going to label this one R1 and R2. Okay? There's 2 R's because we can't do them all together because they have different bottom. They have different bottoms. Right? So if they have different bottoms, we got to do them separately. So R1 and R2, and then we're going to add them together. So for R1, the red is the top. That's the square root of x minus the blue, which is y equals 0, right? Y equals 0, y equals x minus 2, and then y equals square root of x. Okay? So it's going to be minus 0. Right? R2, the red is still the top, but then the green is the bottom. The green, which is x minus 2. So I have to find the area for both, add them together. And then I'm going to add R1 plus R2 to get my answer. Okay? So when you, and then I haven't found the bounds yet, right? What are the bounds for R1?
0 to 2.
0 to 2. And what are the bounds for R2?
2 to 4.
2 to 4. Again, if you didn't know that, if you're like, is it 4? Is it 0? Is it 2? I'm not quite sure. See where they cross. Right? Where the red and the blue cross, that's going to be here. Where the red and the green cross, that's going to be up here. And then 2 is right there. Okay? All right.
It all equals 5 and 1/3 because it keeps going up 1 3 2 3.
So for R1, I got 1.886.
Yeah.
Okay. For R1, I got 1.886. For R2, I got 1.448. Or did you guys get something different?
I got 3.44.
That seems a little high. Let me see.
8.
Let me double check. Let me double check. Okay, so here I got,
Oh, that's what I did wrong.
oh, okay, you saw?
It added the previous value for some reason.
Oh, okay. So would you, so would you get, so verify you got 1.448 for R2. 2, 4, parentheses, square
Yeah, I
root.
got 1.44.
Okay, good. Minus x minus 2. Yeah, 1.448. Yeah.
So you got 4.895.
No, that's not what I want. So that's R2. So when you add them up, right, you get 1.886 plus 1.448. I got 3.33 something.
Yeah.
3.4. That's the total area there. Okay. Sometimes you're going to have to do that. Sometimes you're going to have to get creative because the blue isn't the bottom for the whole thing. The green isn't the bottom for the whole thing. Sometimes it's one, sometimes it's the other. You don't know that. Again, you do not know that until you see a picture. That's why a picture is important. Okay, that's why I said, first rule was if they don't give you a picture, draw a picture. Use the calculator, draw a picture. Okay? Okay, so that's if we're doing that type of problem. There's another type of area that we need to find.
Both of them?
Say what?
Both in between and below?
So this one's still in between. This one's still in between curves. But this one is with respect to y. So what do I mean by when I say respect to y? X equals things, right? We're used to seeing y equals, f of x equals, right? We see that a lot. With respect to y means when it's reversed, when it says x equals something. You see the next example, x equals, and then you have a y equals, right? So this one's going to kind of be a little funky. So first thing I want you to do is graph that, draw a picture on yours, and then we'll explain it. So the first thing I'm going to do, draw a picture, look at your graph, see what you get. Okay. Go up to the graph. That's what it looks like. So navigate, remember, is how to like line it up. So if you want to so when things are x equals, they're not functions. So that's why you have the sideways parabola, like the red sideways parabola. They're not functions, right? It doesn't pass the vertical line test, right? Ezekiel, do you know how to do x equals and stuff like that on that calculator?
I'm trying to figure it out.
There's a way to do it. I remember a student told me last year, there's a way to do it on those calculators and it's not hard, but I forgot, for the life of me, I forgot how to do it.
Does it still work if you just solve for y?
Yeah,
Oh,
yeah, it'll still work if you solve for y, yeah. Mm-hmm. Yeah, I gotta dig my TI and play with it a little bit. I'll try to play with it and tell you tomorrow how to do it, yeah. Because there's a way, yeah, I didn't think there was a way, but then a student last year, I think she showed me how to do it, and I was like, that seemed very easy. So yeah, I gotta just think about it for a second.
Press random buttons.
Yeah, I guess, yeah, she's just like, oh, just do this, and I'm like, oh, that worked. Okay, so, all right, so we got this guy, right? And it says that it only wants the area, so that you see the area bounded is this part here, but it only wants the top, the first quadrant. The first quadrant is where everything's positive. So that's going to be here. I'm going to use a different color since they use green. I don't want to use green and green. This is going to be the area bounded, right? Because they just want the top, they want the first quadrant. So this is going to be my R. Okay.
Mr.
Mhm.
Forrest, how do we get the yellow stuff right there?
The what yellow stuff?
Like the yellow thing's like a cosine. Because there's an equal sign right here.
Hit shift.
What am I doing wrong? Tell me now.
Oh, the
It's like a J. There's pi again.
yeah, I'm not sure.
Huh.
Okay, so this one. This is where it's different. We're not going left to right. The bounds aren't left to right or top to bottom. Okay? So let's do this one by one. Okay. So I'm not worried about the bounds yet. Don't worry about the bounds. We'll deal with the bounds later. The right curve, the curve that's on the right side. What color is on mine? What color is the curve on the right side of the R? It's the blue guy, right? The blue guy is holding it in from the right side. That's going to go first. That guy is x equals y plus 2. Okay, so we're going to put y plus 2. Why did I put equals there? That shouldn't have been there. Y plus 2 minus the left. What's committed in from the left?
The red one?
Yeah, the red, the parabola, right?
Which
Which is y squared. dy, when it's with respect to y, I can only have y's in there. Okay? I can only have y's in there. So now let's do the bounds. It's not left, right. It's top and bottom, and you're using the y values, right? So yeah, so this is going to be, it's going to be, one of them's going to be right here, and one of them's going to be right there, right? The top bound is 4, 2, right? We only use the y, so that's going to be 2. That goes up here. The bottom is where y equals 0, right? So that's why 0 is going to go down here. When you put it in your calculator, you don't have to use y's. You can just put x's. X's are fine. You can use y's too. To use y's, you got to hit alpha, that alpha button, but it's not required to do that. You're going to put it in the calculator exactly how you've been doing it. It's not going to change anything. So if you put x plus 2 minus x plus 2 dx, it's okay. The only time the calculator will have a freak out is if you try to put y plus 2 minus y squared and it says dx.
Yeah,
The calculator will have a freak out because it's like, what are you doing, right?
3.333.
So you got to keep the letters all the same. So yeah, when you do it, it's like 3.333. It's 10 thirds. 10 thirds, which is 3.333, which is equal to 10 thirds. Okay. That's the last type of problem. Okay. So we have one more of this. We'll do it tomorrow. I don't want to do it today because tomorrow that's going to be a good problem to use. So we're going to do that last problem tomorrow, and then the rest of the time I'll give you to work on your practice. Okay? Yeah, I'm going to give the practice. I'll give you guys practice tomorrow.